So, yes, welcome once again. Welcome to Life After Code in Place 2025. This is a number, of sections, sessions, whatever you want to call them, that we will be doing based on the CS 106, the continuation of the CS 106 program in Stanford, because as many of you might know, Code in Place is actually only the first half of CS 106. And the reason why this is actually happening is because last year, so the Life After Code in Place's debut was last year. And the way it happened is that actually Vicky, whom you probably know more than me from the forums, was a student of mine. And at a certain point when Code in Place was coming to its end, Vicky said, well, I don't want this to end. I actually want to continue learning, and I would like to, go through the entire CS 106 program. But the issue is that, there is always the question of motivation. When you are alone, it's a bit harder. So how about we do this program together and invite all the people who would like to participate? And that's basically what we did. And the attendance of Code in Place last year was, I think, twice. It was half as large as this year. So it was about 10,000 students, and I think this year it was about 20,000 students. So probably the number of attending people Life After Code in Place this year is going to be higher. We already see that's like 80 participants. With Vicky, we had a small bet. We decided to guess how many people would show up. And we actually named a number which was very close. Vicky said 55 and I said 54. So Vicky wins. And this year, when Vicky said, do you want to do this again? I said, yes, I do want this again, because it's fun. It's exciting to see so many people who want to continue learning after sort of the formal Code in Place is over. And I know that many of you will probably be watching this as recordings. So if you are watching this as a recording, hello. This year, we're going to be doing this at different times. I will not be doing this every week, because there will be other lecturers, other speakers, including Chris. Vicky mentioned Chris, who is from Google. So that's a bit of a introduction for week 2. It's me. My name is Alexander Belyakov. I was not as active on the forums as I've been in previous years. This is my 4th year as a section leader. So many of you don't even know my name. This is the first time you've seen my name, unlike Vicky, who has been very active as a section leader this year. So with these introductions, I would go into, some organizational things before we actually get into the nitty-gritty of today's session. This is a welcome. Vicky is a big fan of Kevin and Hobbes, if you know this comic series. So there is always a quote and a picture from Kevin and Hobbes in our presentations. And maybe before we go into organizations, Vicky, maybe you'd like to introduce yourself as well, though I'm sure that people know you more than me, and say a couple of words about this entire thing.
I just wanted to echo Alex's sentiment. Very happy to see you guys here. I think Alex already told you about um, who I am. I'm actually a first-time section leader, and the only reason I signed up for this was because Alex was my section leader last year, I don't have any coding experience, no CS engineering background. I was a Stanford undergrad, almost like more than 25 years ago. I was a pre-med. I ended up going to Harvard where I got all of my medical training, and now I actually work as a cancer doctor. And I never thought that my professional world would ever collide with the coding world. But in my work, was also doing research and wanted to learn Python. And I've actually took a lot of different workshops, courses like Coursera, whatever, and then never finished it or never learned it until, I had Alex as my section leader last year. So I would say Alex is kind of like Bill Belichick in the year 2000 that turned the New England Patriots around from like a bottom of the barrel team to actually like a contender. So very impressed that he was able to turn me, who had like no interest in coding, into someone who could actually code and then even section lead. So I would highly encourage you to pick his brain for the next whatever umpty weeks. It's very kind of him to do this because he's a very busy person dealing with a sick cat, as well as a newborn. And so I learned a lot from him, and hopefully you guys will too. So thanks.
Thanks, Vicky. So one more thing that I would ask, ladies and gentlemen, please watch your microphones. Please mute your microphones if you are not speaking, so that we do not get, extra audio in our session. So let's go. Several organizational things that we need to discuss. First and foremost, we need to say that Life After Code in Place is not sanctioned in any way by Code in Place or Stanford in general. This is something that Vicky and I are doing together, has no connection to Stanford, besides the fact that the topics and the problems, the assignments that we're going to work on are from Stanford. What this means is that there will be no certificates. Please do not ask us for any recommendations, how to get into Stanford or how to get a certain job. We will not be able in any way to help you with that. So this is for the pure fun of learning. We are here to learn and not to get, something to put on your wall. And one of the important things that I would want to stress is I would prefer this to be not, one-way monologue from me. I would encourage active participation. And what I mean by that is in Code in Place, you probably encountered, although I understand that the experience may vary with the section leader, but still you probably worked interactively with your section leaders in sections to solve this or that assignment. And we will do this as well in Life After Code in Place. We will be using breakout rooms. We will be using, I will be like calling you out in order to solve problems interactively together. So the reason why I have this hand icon here is because many of you may know that in Zoom, you might be able to raise your hand in order to show that you want to to say something or to interact in some way. So what I would like to ask right now, because I'm trying to see myself and I once again, for some reason, I can't find the reaction button. Can you guys, if you see the reaction button, can you actually raise your hands right now so that I would see that this works? Okay, I see Vicky, I see Melissa, Grace. Okay. So I'm starting to see raised hands. So the way we're gonna use the raised hand icon is the following. I do not want to cold call you, in the sense that if you do not want to, participate in discussion, this is not a school. I'm not going to say like you have to participate or else. If you don't feel comfortable participating, fine, that's good. But if you do want, I would ask you to raise your hand so that I would actually see you in the list of people who, would like to participate. And I will call you out. So for instance, right now I'm looking and I see that Mansi is the first person with the hand raised. I would say, like, in this specific assignment, Mansi, what do you think we would be doing right now? You would give me your proposal, then lower your hand. I would ask the next person, and so on and so forth. And then you would be able to raise your hand again if you want to participate again. So I would encourage you to use this option so that we do not lose time on me asking people who do not actually want to answer, and participate in the discussion. Everyone is free to either do this or not do this. So for now we can lower hands. Thank you. I see that this is working, so that's good. Next thing, we will be sharing assignment links 2 weeks in advance in the main forum. We will be, from what I understand right now, we do not have the infinite ability to pin our posts, because posts are usually pinned by Stanford. And the reason why our current post is pinned is because Vicky spent a lot of time talking to Stanford people and asking them to pin the post. But we will be using the LACIP tag on our posts so that you can filter them using the search option. If you type in LACIP into the search bar, you would get all the posts which are connected to our. And the first week, like today, we're going to talk about assignments that are in the Beyond Code and Place section in CIP. So this is actually something that is available, and maybe some of you already worked on these assignments. Maybe you even went to some event where these assignments have been discussed, but it's okay. I mean, even if you've done this, you're more than welcome to participate today. And we strongly encourage you to preview the topics that we're going to discuss and try to solve the problems before our sessions, because that's going to be more fruitful than just coming in without any preparation. I know, all of us have jobs, real lives, etc. And if for some reason you cannot, then obviously you can still, come in and participate. But it's a lot more useful to actually try things yourself before coming here and seeing how, we as a group solve them. I already talked about recordings on YouTube, but I will repeat this again. We will not edit these videos for privacy. So recordings will be posted on YouTube. And if you would like, or you do not like your name or your face to appear in these videos, please change your name in Zoom. Please turn off your camera, because we will not be able to edit this for privacy in any way. If during our program you have any questions that you would like to ask, we will be using the main forum, and we would ask you to use the LACIP keyword in your topic so that we can immediately see your questions and reply to them. It's not just going to be Vicky and me. We also have some people who are either SLs or even TAs this year. For instance, I think I saw Emma in one of the videos. I cannot be sure because I don't see everyone, but Emma, if you're here, can you give a shout out?
Hi everyone. I'm really happy.
Yeah, there you are. There you go. So yes, Emma agreed to help us out with Life After Code in Place as well. So thanks a lot. Emma is not the only person who helped us, who agreed to help us. So we'll have some SLs come in, especially during breakout rooms, to sort of help you move along, because I see we have almost 100 participants. So that's going
Bob
to be
is also here.
Breakout rooms. Sorry, Vicky?
Bob is also here.
Okay, Bob is already here.
Good afternoon, everybody. Hello.
You could do the breakout first, if you want.
I already have changed the order, so not to jump back and forth. And last but not least, we obviously expect everyone who is participating to be professional about it and to adhere to a code of conduct. So basically what we're saying, be gentle, be helpful to each other, do not critique each other. I mean, we all come from different backgrounds, different knowledge of coding. So try to be civil about it. I mean, if we encounter some behavior that we find to be offensive, for lack of a better word, we reserve the right to remove the offenders from the course. But I sincerely hope that we will not come to that. And last, if you have any questions, suggestions, or feedback, you can not only post them in the main forum, but also there is a special email address, which is called carolcip2024@gmail.com. You can send emails to Carol, and sometimes Carol answers. So there you go. And I think that's it in terms of logistics. We needed to do this in the first section. So now let's briefly talk about the schedule for the next 5 weeks. Today's week 1. We're going to work on Fizzbuzz, Follow Me, and Baby Snake problems from the Beyond Code in Place block of CIP. And then the next week, we're going to talk about data analysis, GitHub, and Jupyter Notebook, and that's where Chris is going to come in. And if you look at the time, it's going to be July 3rd, and it's going to be actually 4 p.m. Pacific time. So it's not going to be the same, 7 a.m. Like morning Pacific time. It's going to be late afternoon. So on week 3, it's going to be me again. I'm going to talk about 2 more assignments, 2Sum and Breakout. That's going to be on July 11th, once again, 7 a.m. Pacific time. Week 4, once again, Chris is going to talk about NumPy. So we're going to continue talking about data and working with data. That's July 17th. Once again, it's going to be early evening Pacific time. And week 5, actually, Vicky is going to talk about images. That's also going to be evening on July 24th. So this is the first 5 weeks, and we will update this schedule, as we move along. And now the last thing we're going to do before we're actually going to talk about assignments, Vicky has prepared a small quiz for you because, well, Vicky, why don't you tell, everyone what's going on?
Yeah. So I think one thing that really helped me last year was actually active participation in these sections, because at least the reason why I couldn't really learn programming before is because, I didn't have somebody to like motivate me. And then, after you kind of watch a couple webinars and videos, I just kind of like gave up because life is always busy, right? So we would really, really encourage, even if you're really busy, before you come to these sessions, to at least look at the material. It would be even better if you like try to attempt the problems, but if you can't attempt the problems, just at least like look at the material and then look at the problems instead of like passively just like be in awe of like Belyakov's like coding skills. Okay. So in order to actively promote people to come to section, because we know you're like everywhere in the world, okay? And then like 7 a.m. is very early, especially for those of us who are on the West Coast Pacific time. So thank you, Emma and Bob, for being here, for getting up early. So we're going to have these like intermittent quizzes, okay? They're going to be like scattered throughout the lecture, and we might not have them every week, but you can actually win prizes, okay? They're not going to be like $1,000,000 or something, but there'll be like something like a small Amazon gift certificate for you to go get coffee or something, and then they'll be in US dollars. And so if you're somewhere in the world, okay, even like a small US dollar could potentially go a long way. And so you have to actually be here in order to answer the questions in order to win. Okay. And I'm not going to tell you which sessions we're going to have them. I'm not going to tell you when they're going to appear. And so it's just like an incentive to try to get people here. Okay. To try to help you learn. And so the way this is going to work is, on the next screen, Alex is going to show you a picture. Okay. And so this is time to test your internet speed and your finger skills and your typing skills. Okay, when that picture appears, it's going to ask you where it is and the country where this place is. Okay, and so I'll be monitoring the chat. The first person to type the place and the country will win. Okay, and then I'll like reach out to you individually via the chat, and then you can tell me your email, and then I'll send you the gift certificate. Okay. And so if you hate this, you don't have to participate. You could send an email to Carol and say, like, Vicky, this is like so stupid. Do not ever do it again. And then, we won't do it again. But this is one thing we thought we could, add some fun for the people who have to get up very early or in the middle of the night to come here. Okay. So take it away.
Shall we? Let's take a look, ladies and gentlemen. Please look at the screen. You will now see a certain photo, and you will have to name the name of the location, the city, and the country. Here we go. Let's look at the chat. Who is the first person to name this place? Okay, we have some answers, but I think Grace is the first person to actually answer fully.
Correct. Yes.
Yes.
So, we needed the location, the city, and the country. And so the first person to type in all three is actually Grace. So we have a winner. Yay. Oh, and then we have another SL that just joined, Jake. Um, so, um, so Alex, somebody actually requested, okay, can one of the future prizes be a one-on-one session with you? I mean, I think
I think it can be arranged.
could be arranged, right? Okay.
It
All right.
could.
Okay. So,
All right. So Grace,
I will
congratulations.
reach out to you individually, Grace. Okay. Okay.
Okay, super. So yeah, we're gonna have some fun quizzes like that. Vicky, thank you very much for sponsoring these. This should be fun. And yeah, some actually additional info about the Forbidden City. Do you care to talk about through this as well?
Oh, okay, so the Forbidden City has like 999.9 and a half rooms, if you've actually never been there. And the reason it's like have that half a room is because it's a palace on Earth, and then this perfect number of 1,000 can only exist in heaven. And so for those of you who've never been there, the Forbidden City has no nails. Okay. Everything, I mean, the whole structure is built with like interlocking wooden brackets. And that's actually one of the reasons why it could actually withstood, thousands of years of like earthquakes. And then one thing I did not show here is the Forbidden City also has a very extensive water draining system. If you were to go on a very heavy rainy day, okay, on these porches, there are these dragon heads, and so the dragon will actually spout water from their mouth. That's like how the Forbidden City like drain its water. And then you'll also see one thing about the Forbidden City is that you don't see like birds pooping on the roof tiles. And that's because the roof tiles are sloped and they're very, very like smooth, and the space between these tiles are pretty wide, and so birds cannot stand on them. And while I'm on the subject of Forbidden City, as some of you guys know, okay, I'm also a big, huge fan of this Chinese movie star by the name of like Liu Xueyi. And so I can't resist and have to put in a plug that he has a new show that just aired like 2 days ago on Tencent. And so I would hope all of you guys to support him. Okay. Okay. So I'm going to stop talking, hopefully for the duration.
All right, so that was the quiz, and now I think it's time to actually talk about today's plan. And today we're first going to discuss a couple of Canvas methods to do a brief recap, because then we're going to talk about the follow me problem, which would require using those methods. The second thing we're going to do, we're going to work on the Fizzbuzz problem. And before that, I'm going to talk about functions and do a recap of functions, because from my previous experience, functions is something that is not as easy to sort of wrap your mind around as many teachers would like. So I think this is, 15 minutes well spent. And then the rest of the time we'll be working on the baby snake problem together. So that's the plan. Obviously, we already used up 26 minutes of our time, but this is the first section. So we needed to go through some of the organizational things. So let's start with some of the Canvas methods which we would need to solve the first assignment. First of all, in the graphics module, which we have in Code in Place, we have canvases, and these canvases have a number of methods. And methods, the word method means a function which applies to a certain data type. Canvases are data type. You could say that they are data types in the same way that integers are data types, or strings are data types, or lists are data types. You also have canvases. And two very useful methods are getMouseX and getMouseY. These two methods allow you to get the X and Y coordinate of the mouse, at the time when this method is called. So you can actually learn where the mouse is located on the canvas using these two methods. Two more methods that we're going to use, which are helpful, are move and move_to. And these two methods allow you to actually move objects on the canvas. So if you draw something on a canvas, be it like a circle or a rectangle or an image, you can then move them. And the difference between these two methods is in that the first one, which is move, allows you to move an object by a certain number of pixels. So it's relative to the object's current position. For instance, move it 10 pixels to the right, or move it 20 pixels up. That's where you use move. And the parameters for this method are the object itself. So you have to name the object, which object you're moving, and then how much you want to move it by horizontally in X and vertically in Y. And as you probably remember, if you have for X, positive numbers move to the right and negative numbers move to the left, and for Y, positive numbers move down and negative numbers move up. So that's the move method. The other one is move_to. And the difference is that it's an absolute coordinate. You're saying move an object to a very specific set of coordinates. Here is the X, here is Y, move the object there. So with the first one, you can move like in relation to the current position. With the second one, you can just give an absolute position and say like move the object there. And in the problem that we're going to solve right now, you will have to decide yourself which one of these two methods we're going to use. And the last thing, which not everyone knows, there is a module which is called time, and the time module deals with, things time. You need to import this module separately because it will not work if you do not import it. So to do this, you need to import space-time, and then one of the functions which we're going to use is the sleep function. So the sleep function pauses the program for a certain number of seconds. So the number of seconds is actually the number that you list inside the parentheses. It can be a floating point number. So for instance, if you want 100 milliseconds, you need to write 0.1. That would be a tenth of a second. And the way you write this is time.sleep, and then in the parentheses, the parameter, which is the number of seconds, and the program will actually stop for this specified time before, continuing to work. So with all of this in mind, some of you may want to, take a screenshot or take a photo of this slide, because now we're going to discuss the follow me assignment, which we're going to work on together. The assignment is the following. We already have some boilerplate code in which, I see that someone can actually draw on the screen. Please stop doing that. We will have a loop, and inside this loop, we will have a continuously updating X and Y coordinate of the mouse. So at any point in time in the program, we will know exactly where the mouse is located. And what we need to do is draw a blue circle of a given size. We will have a constant which is called ball diameter. And this circle has to follow the mouse. So it has to be centered on the cursor. And when I say centered on the cursor, take a look at two images. So this image is incorrect because here you see the cursor is here, and the image is, drawn. You have the top left corner at the cursor. But this is not what we want to have. We actually want the circle to be at the center of the cursor, or the other way around. We want the cursor to be at the center of the circle. So you will actually have to offset when drawing the circle. So it's not like this, but it's actually like that. You will have to move it up and to the left by a certain amount. And as you can probably guess from basic geometry, this is like half of the diameter, also called like radius of the circle, by which you would need to move to get this effect. And also there is a bonus assignment. We can try doing it if we have time, how to make it so that the circle does not go out of bounds if the mouse goes out of bounds. So once again, if you take a look at two images, this is what we're trying to avoid. You see that the mouse goes outside and the circle sort of starts disappearing. You only see a part of the circle. We want to write the program in such a way that the circle is sort of bound by the edges of the canvas. So the circle cannot actually go beyond the canvas. It has to stay on the canvas in its entirety. So this is the assignment which we're going to work on right now. We're going to work on it together. So here is where I'm going to ask you to raise your hands if you want to participate, and I will call you out and ask you to help me write this program so that we actually do it together, and it's not just me coding and you watching. I have this image of Uncle Chris. Uncle Chris says that he wants you to code follow me, so let's do that. And just give me a second, I will switch my screen to the code in place ID so we can together look at the code. And let me quickly look at the chat, because maybe there are some things that are I'm not seeing the chat because I have the
we're good on the chat, and so you've got 4 section leaders helping you answer questions on the chat, and then we will alert you if there's something that you need.
Thank you. Yes, if there is a question, please let me know.
Yeah,
and I will answer it promptly. Okay, so just give me a second to change the screen to the actual code in place IDE. See my screen right now. Let me make the code larger. Is it visible right now, the IDE?
Yes, it is visible. If you could make it just a tad bit bigger, it might be a little bit easier to see.
Is this good?
Yeah. Okay,
excellent. So first, let's take a quick look at the boilerplate that we have here right now. We have several constants. The first constant is canvas size. So as you can see here, it's going to be 400 by 400. If we run the program right now, we will get this square canvas and a circle in the corner, which is obviously not following the mouse for now. Here is the code that actually creates the ball. So we're using the canvas.createOval from the graphics module. And if you remember the syntax for creating an oval, you first need to provide the coordinates of the top left corner. So in our case, it's 0, 0 right now. So that's why it's in the corner. And then you have the coordinates of the lower right corner. And in our case, we have a constant which is called ball diameter. It's 50 for the moment. We can obviously change it at any time. But right now, the top left is 50-50 because of that. And it's blue in color, which is what the assignment asked us to do. And then we have an endless loop. So while true gives us an infinite loop that goes, forever until we stop the program. And what this loop does right now is actually get the coordinates of the mouse. So you can see in the terminal, I unfortunately cannot make the terminal larger, but you can see the terminal constantly scans and gives you the coordinates for the mouse location, the X and the Y, thanks to these two lines in the code, which update at a quite high speed. And what is the speed? Actually, we have here pause time. Pause time is 1/50th, so 50 times a second at the moment. We can also change this if we want, but this is a good time. So 50 times a second, we are checking what the coordinate of the mouse is and saving into these two variables. We have the variable mouse X and we have the variable mouse Y. So now we actually have to write the code to make the circle follow our mouse. So if the mouse is here, we need to have the circle also drawn here. And here's where I'd be more than happy to, ask some of you out. Please raise your hand. So Anna, I see your hand first. How would we start doing this? What would be the first line that, we'd write here? What do we want to do here?
Yeah, to do write code, we'll write canvas.move to. We are going to use the move to function.
Okay, so we're going to use canvas move to. Why do you think we need to use move to and not move?
Yeah, because we want the ball to follow the pointer.
Yes.
Yeah, so we want the exact coordinates and not the relative ones.
Okay, so I agree. Move to is a good decision here. So do you remember the parameters that we need to pass?
Yeah, first would be the object, so it would be ball.
Yes, because we called our object ball here. So the first parameter is ball.
Then comma. And then we have to give the x coordinate. So that would be mouse underscore x, which is the what do you say? Which is getting the canvas dot
coordinate
get
of the
mouse
mouse.
x.
Yes.
Yeah. And we have to subtract minus.
Yeah.
And within brackets, ball diameter divided by 2, because we want the radius of the circle.
So ball diameter divided by 2, I would use here integer division to make sure that this is an integer. I don't think it's necessary, but to make sure it's an integer, I would do this. Okay, and then the next one?
Then the y parameter would be mouse underscore y.
Yeah.
And minus within brackets, ball diameter, and then again double slash.
Yeah, 2. Once again divided by 2. Okay.
Yeah.
So this looks good. Let us try and see what happens if we run this code now. So as you can see, we actually have the ball following now the mouse. The reason why this works, once again, is that we have the coordinates and we use these coordinates to tell Python where we want the ball to be placed. But the important thing why we need to use ball diameter here, let me show you if we remove ball diameter, what will happen. Because the initial thought could be, why don't we just use mouse X, mouse Y? And if we do that, we will actually have the top left coordinate of the ball follow the mouse, which is not what we wanted. We wanted the center. So we actually have to offset. We have to offset by the ball's radius. And we all know from geometry class that a radius is half the ball's diameter. So that's why Anna proposed, subtracting half of the ball diameter. The only thing I would say, which is not obviously an error, but you do not need the brackets, for the simple reason that division comes before subtraction, but sometimes it's actually a good idea to include brackets just to make it visually clearer what the order of mathematical operators is. So I don't have any issue with that. Let's keep it the way it is. So Anna, thank you for providing us with this single line, which basically solved the assignment. Now, remember, one of the things that I proposed trying to do is actually making sure when our mouse goes outside, be it to the left, to the right, up or down, that the ball does not leave the canvas. So I want it to stay like this even if even if my mouse goes here, or stay like this if it goes here. So once again, I would like to to ask you if you have any idea on how we could do this. Please raise your hand, and we'll have a chat how we can solve this issue. Anyone, even if it's not code, we can, discuss this in human language first. Okay, I see dx. So, what are your thoughts on the subject?
Hello, can you hear me?
Yes.
Oh, great. I think we need to set up a condition for the Kevin's move to, like, if most x is less or equal, no, more or equal to the diameter or something. Yeah.
So if mouse x is more or equal to the ball diameter, okay.
And also, so that's the minimum. We also need to set up the maximum. The maximum would be the length, no, x, the y's minus ball diameter, similarly.
But from what I understand, you're talking about the two different parts. If we're talking about x, we're talking about the left edge and the right edge. Do I understand you correctly?
Yes.
Okay, so the condition mouse x is more than equal to ball diameter, which one would that be?
Then we can do the move 2. Otherwise, we should not do the move 2.
Ah, okay, so, all right. So if it's like this, do you want to include the second condition here as well?
Yeah, we should have like 4 conditions.
Okay. So how do we place 4 conditions in one condition?
And.
So you're saying
sorry.
if mouse is...
should, let me see. So the x is from here. It should be end.
So if mouse x is more than equal to ball diameter and mouse x, so what would be the second condition?
Less or equal to the y's minus. Sorry.
To the what? Sorry. I could hear the clock timing. So one more time, mouse x is less or equal to
the waist of the Kevin's. Sorry, it's my bell.
Oh, you mean the size, the canvas size?
The Kevin's size.
Yeah.
Minus ball diameter.
Okay, ball diameter, because we know that we're looking at the top left coordinate. Okay.
You also need to set up the y. Y is similar.
Okay, a similar thing to y. So we're going mouse y is actually more or equal to ball diameter. And mouse y is less and equal, correct me if I'm wrong, but the idea is the same, canvas size minus ball diameter. Is that the idea?
Yeah, that's my idea. I think that all should be.
Okay, so if this is a complex condition, so the complex condition consists of 4 simple conditions which are connected by the AND operand and operator, sorry, with the AND operator. And if we want this entire condition to be true, we need each of these simple conditions to be true. So this has to be true, and this has to be true, and the third one has to be true, and the fourth one has also to be true in order for this entire complex condition to be true, and in order for this to happen. Is this correct? Is my logic in line with your logic?
Yeah, I think that's what it should be.
Okay, so let's take a look and see how this works. So we have the ball following the mouse. So this is obviously working. Now let's try to go outside. And here you see we have a bit of an issue here. The same issue here, the same issue here, and same issue here. So It seems we've taken a bit too much.
Too much.
Okay, so how do you think we can solve this issue? Do you understand what this is? If someone else has an idea, also raise your hand. We'll talk. Vicky, what's your take on the subject?
So, what I did, just for the sake of time, was I basically defined two variables. I called it constraint X and then constraint Y. And then basically for the constraint of X, okay, I basically, um, well, if I could just share,
No, let's talk through it.
oh, okay. Well, okay. So basically for the constraint X, okay, what you want is to define the minimum value of X, um,
Okay.
such that it doesn't allow it to go off the screen. Okay.
Okay. How would we
Um,
do that?
and then I believe that minimum value of X should be the radius of your ball. Okay. Um, which happens to be the ball diameter divided by 2. Okay.
Okay.
Um, this is very similar to the problem we had in section of generating all of those spheres. And then the maximum would actually be the canvas width minus the radius, which is the ball diameter divided by 2. And then you have the
Okay.
same logic in the y direction, okay? You basically have a minimum y as well as a maximum y. And then once you have defined this range, okay, um, you could just take that and then put it into your canvas move to. And then since you want the midpoint to track your mouse, okay, you would also need to actually subtract the radius when you are using your move to function so that
Yeah.
the mouse is actually tracking the center point of your mouse. If you don't subtract out the radius, it will actually be following like a peripheral point.
Right.
That's how I did it.
But then the question is, do you think this is something which we could use here in the solution proposed here? Because obviously here we are using diameter where it seems we need to be using the radius.
Yeah, I mean, because the ball diameter, that's the diameter of the circle. And so you could just like either take that value divided by 2, or you can define a radius um, um, a,
Constant.
a radius variable and then to call it like ball diameter divided by 2.
Right. I would actually do it as a constant. I would here say ball
Yeah.
radius equals ball diameter divided by 2, and everywhere inside the code, I would actually say ball radius. Here also ball radius. Here we also have, by the way, ball radius. Now we don't need the parentheses. Ball radius. Here we also have ball. Ball radius, and in the condition we need to fix this. I think I changed this everywhere. Let's see what this gives us. So here we still have it working. If I come to the edge of the screen, you see it's difficult because you have to be very deliberate and slow with your mouse to actually get to the edge, but now you see that it's working. And the same here. And it seems we got the result that we wanted. The reason why, for instance, I do this, and we have this space here, is because remember, we're checking the coordinates 50 times a second. If I move the mouse fast enough, the code doesn't actually have the time to see when the ball is here. The last coordinate it sees is somewhere here, and then, since the mouse jumps off the canvas so quickly, it does not get the edge coordinate. So that's why sometimes it does not reach the edge of the canvas. But in any case, no matter what I do, it will never leave the canvas. So good job, Dee. Vicky, thank you very much for your insights. I mean, together we managed to solve this sort of small warm-up problem with the bonus assignment as well. So I think this was a good first dive into our life after Code in Place. So yeah, we're done with the first one. I think we can close follow me. We will probably, I'm just thinking, will we post code in the main forum so that people have access to it? This is actually an open question. I have not considered whether we'll actually post the code and where we'll post it.
Well, you have posted the code last year. And so what I could do is I could make a folder and then upload it onto Google Drive. And so for people that want the code, you could just download it from the Google Drive every week. But if you want to like struggle through it yourself, you can struggle through it. And then if you're really stuck, the solution will still be there for you.
Okay, yeah, we could do that. So before we move on, let me know if there are any questions on this code. Please raise your hand if you have a question. Maybe you don't understand something here, you need some clarification. I'd be more than happy to walk you through it before we go on to the next assignment. So I'll give you like 10 seconds to raise your hands if you do have any questions. And I'll take a quick look at the chat. And yes, I see comments that some of you solved this differently. And the beauty of code is that for any assignment, no matter how small the assignment is, there are many different ways of solving it. And the way I solve this, for instance, is also different. I actually changed the mouse X and the mouse Y coordinate using a condition saying if the coordinate, for instance, is less than 0 or less than ball radius, make it the ball radius. If it's higher than the canvas width minus ball radius, make it that value. But that's the beauty. You can solve it in different ways. Coding is as much a science as it's an art. And there are always different ways of doing this. So yeah. Sorry. So let's go on to the second assignment. Let me share my screen once again, reshare my screen. And we'll go back to Uncle Chris. I hope that Uncle Chris is happy with us having solved the first assignment. And let's now talk about the second assignment, which is going to be Fizzbuzz. And before we actually get into Fizzbuzz, I wanted to talk about functions. And the reason why I want to talk about function and rehash this topic is because understanding how functions work is very important to writing good programs. And there are different things which you need to understand about functions, but the basic thing is whenever I teach students about functions, I say the following. I say that a function, any function you take, is like a black box. And the reason why I say it's a black box is that you do not need to understand what's happening inside the function. You don't need to understand how the function functions. You need to understand only several things in order for you to make use of any function. And here I usually say, for instance, if at home you have a microwave oven, you do not need to understand how a microwave oven works in order to make use of it. You do not need to understand, physics and microwave particles and what have you, electricity. You just need to know that, you need to press button X and Y to get, your food defrosted or cooked or whatever. So functions are just like that. A function performs certain actions. if a function doesn't perform an action, it's useless. So there is something that a function does, much like a microwave cooks your food. Any function does something. Some functions get input. So basically you can tell a function, give a function some data and say, you know, dear function, here is some data that you need to work on and use in your actions. And some functions provide something, you know, like output. So they give you something in return. They take your data, they perform some actions on that data, and then they give you a result and say, like, here is the result. And once again, if we go to the microwave metaphor, the result is the cooked food that you get. In terms of input, you get some frozen food, you give, you know, the time, you give the how many watts you want your function to use, and the result that's given back to you is the cooked food. And the data that we input into the function, like the specific values that we input into the function, in programming, these are called arguments. So if you would say, I want to cook this, I don't know, macaroni and cheese for 2 minutes at 800 watts, those would be your arguments. The macaroni and cheese would be your argument, 2 minutes would be your argument, and 800 watts would be your argument. And these arguments are passed into something which inside the function are called parameters. And parameters are basically variables which are used only inside the function. So in our case, we could say there would be 3 parameters. For instance, the first parameter would be food, so the type of food that you're cooking. The second parameter would be time, so how many minutes you would be cooking it. The third parameter would be called, I don't know, power. You know, how many watts of power you're going to be used for this specific cooking procedure. So those are 3 parameters which will receive the arguments. So you would save macaroni and cheese in the food parameter, you would save 2 minutes in the time parameter, you would save 800 in the power parameter. And then your function would actually work with these parameters and produce a result. And the produced result is what's called a return value. So return value is something that the function returns to you, it gives back to you. In the case of our microwave, the return value will be a cooked meal. And like these arrows show you the logic. Arguments go into parameters, parameters are used in actions, the actions performed sometimes give you back a return value that then you can use inside your program. And for instance, let's take a look at the different function definition. Let's say we are writing a function which calculates the power of a certain number. So to calculate, like, I don't know, like 2 to the power of 8, you would need a function which accepts 2 parameters. The first one would be the number and the second one would be the power. And then you would have some code inside. So in order to calculate the power, if you don't have a power operator, would to actually take the number 1 and then in a loop, multiply it by the number of times that you have power. So for instance, if you want to raise 2 to the power of 8, you need to take the number 1 and then multiply it by 2 8 times. So 2 by 2 is 4, by 2 is 8, by 2 is 16, and if you do this 8 times, you'll get 256, which is 2 to the 8th power. And this is the function definition. Num is a parameter, pow is a parameter, result, which is calculated inside the function, is the return value, and a function call is what you actually do to make the function work its magic. In our case, you call the name of the function, which is power, and then you pass in 2 arguments. So these are very specific values, 2 and 8, you know, raised to the power of 8. And these are arguments. 2 is saved into num, 8 is saved into pow, and then it's calculated and a value is returned. And in our case, it would be printed. So you would get the resulting return value here, and then that value would be printed. There are functions which do not have any parameters. They do not accept parameters and they have no return value. These are exceedingly rare and often very useless, but they have their uses. So for instance, this is a very silly function that you could write simply to write hello. You would obviously ask, why would I need to function to write hello if I can just write hello? But for the sake of argument, we do not have any parameters. We do not have a return value. The only thing that this function does is actually print hello on the screen. And some people confuse this hello with the return value. Some people say, well, the function prints something on the screen. Isn't that the return value? No, it's not. Printing something on the screen is actually not the same as returning a value. This is simply an action. The action is to put something on the screen, but the function does not return the result. A second type of function which you could have is a function which does have parameters, but does not have return value. So for instance, here we have a function which accepts a first name and a last name, 2 parameters. So if I were to call this function with my first and last name, say Alex Belyakov, these 2 arguments would be saved into the 2 parameters first and last, and then using an f string, I would actually greet myself or whoever, you know, the name belongs to. So in this case, Alex would be first, Belyakov would be last, and then we'd get the action, which is the printing, and we would get hello, comma, space, Alex Belyakov, exclamation mark. If we were to pass like Vicky here, we would have Vicky's name, etc., etc. So this is a bit of a more interesting function. Next, you could actually have functions which do not have any parameters, but do return a value. So here is a function to throw 2 dice and return the result. So for instance, we randomly calculate the first die from 1 to 6 using randint. We calculate, you know, get a value for the second die from 1 to 6. We call them die 1 and die 2. Then we add them together and return the result. So there is no incoming arguments. We don't have any arguments. The function always throws 2 6-sided dice. But what happens in terms of actions, for instance, the first die gives us a random number 2, the second die gives us random number 5, then we add them together, 2 plus 5 is 7, and this is the result which we return from the function. Note, we do not print it. We do not do anything with it. We just give it back to the program and say you can do whatever you want with this number 7. You want to use it in some mathematical expression? Yes. You can do that. You want to print it on the screen? You can do that as well. So this makes the function more flexible in the sense of what you can do with the value that the function returns to you. And the other time you run this function, instead of 2 and 5, you can get, I don't know, 1 and 3, and you would return 4, etc., etc. And obviously, the last option that you would have, and many functions work like this, is you have a function which has both parameters, both input and return values, the output. So for instance, let's do a more flexible function which actually asks you how many dice you want to throw and how many sides those dice need to have. So for instance, I could call this function with the arguments 2 and 10. 2 is going to be the number of dice, 10 is going to be the number of sides. So I'm saying roll 2 10-sided dice and give me the result. And here, you know, the program is a bit more, is larger. You have the total, which is initially 0. Then you loop inside a for loop a number of iterations, or the number of times, which is equal to the number of dice. So in our case, 2 dice. And then you add the results. Maxi, could I ask you to please mute yourself because we can hear you? Thanks. And we will add those numbers to the total and then return the results. So for instance, in our case, the first, you know, dice would, first the total is 0, then the first die is 9, so we add that to total, the total is 9. The second die, for instance, is 5, we add to total, it's now 14. And then we return the result 14, and the calling program can do whatever it wants with this value. So these are sort of, you know, general 4 types of functions which you would encounter. No parameters, no return value. This is rare. No parameters with a return value. Parameters without a return value, and both parameters and return value. So it's a 2x2 matrix where you have four options. And now let's go for a very quick quiz on the subject to see whether you're still alive and you're still, understanding what's going on. And I would ask you to actually answer, take a look at this small program. We have like the main here. We have the definition of the func function. What would be the result if we did call main here? Just write in the chat the letter corresponding to the correct number. Is it A, B, C, D, or E? We have, here 1, 2, both 1 and 2, or 2 and 1, and option E is nothing would be printed. So what's your answer? I see someone saying 1, 2, that's C. We have B, C,
Alex.
B. Yes.
Alex, do you want me to actually launch a poll? Because I do have a poll on this. They could.
Oh, you do. Sorry. If that's quicker, if that's faster, because I can see it like the answers right now. If you think that's
yeah.
Oh, okay. You launch it. Okay. So we're gonna have like I think 4 of these. We can try, but I saw that most of the answers centered around either B or C, but we have like a plurality, of opinions. But let's take an actual look and walk through this program and why the answer what. Remco, I like your saying, yes, the condition is missing, we don't have the main, but I did say if we were to call main. If we were to call main, what would the result be? So, yeah. I should have written probably, main in there, but yeah, I forgot that. So let's take a quick look at the code. So the first thing that's going on, we are actually calling this function. And when we call this function, the first thing that the function does is print the string 1. The second thing the function does is return the string 2 to main. So basically the string 2 is returned here, and the string 2 is actually saved in the variable result. And then when we print result, we actually print 2. So the order is first we print 1, then we print 2, and the correct answer here is C. So those of you who answered C are absolutely correct. If you missed, I hope this explanation, gave you some perspective into how this works. So the order is print first, that's the function's action, and then the return value 2 goes back into main, is saved into the variable result, and then printed. But let's take a look at another code which is very similar to this one, but there is a difference. I have commented out the second line in main, so there is no more printing the result. What would happen now if I launch main in this specific situation? What would happen here? So Vicky, do you want to launch this again as a questionnaire? I can't hear you. Your mic is off.
All right. This is just a question 2. They should be able to answer in the poll, I think.
Okay, so yeah, let's take a look in the poll now. Most of you are answering A. Someone is answering E, but most are saying A. So let's quickly walk through this again. The logic is the same. We're calling the function. We are printing 1. We are returning 2 into the variable result, but we're not doing anything with the value stored in result because we removed the print. So the correct answer is A1. You're absolutely right. Now, number 3, what would happen if we comment out the print 1 in function? In this case, if you look at this program, which is, very brief, what would be printed in this case? What would be the result? Once again, A, B, C, D, or E. Waiting for your answers. And okay, I see you're getting it. I see you're getting the story. You're answering E. In this specific case, nothing would be printed because once again, we're calling the function. The function returns a value, but this value is not used anywhere. So we're just throwing the value away. We saved it into result, but it's not used. So correct. Now the last one, and this one is a bit tricky. So think for, a bit before answering. The fourth one looks like this. And the difference is that I changed the order of lines in the function. Now we have first return 2, and then we have print 1. What would be the answer in this case? This is the last question.
I'm sorry, I thought you were only having 3 questions, and so the poll only have 3 questions, and so they're going to have to type this into the chat.
Okay, I'll check it into the chat. So this one is interesting because I think there would be 2 types of answers. I can see B's, I can see D's. Most of you are writing B, some of you are writing D. This is important. So the reason why the answer is what it is and not something else, you have to remember this. So whenever inside the function the code comes to the return statement, the function ends right there and then. So in our case, let's walk through the code once again. We call the function returns the string 2, and this terminates the function. There is nothing else happening inside the function. So the code print 1 is actually unreachable. It will never be executed. So the string 2 is returned to main. It's saved in result. It's printed. So the correct answer, all of you who answered B, you're absolutely correct, remembering that return exits from the function, return terminates the function. So, okay, I hope this gave you some insight, into how functions work. You refreshed your memory. I hope this was useful. At this point in time, if there are any questions on how functions work, maybe something is confusing, or you want to ask a question, please raise your hand. I would be more than happy to oblige and answer any questions, because after this we will actually try the Fizzbuzz problem. I'm sorry if I mispronounced the name. I don't know if it's Yishu or Jishu. I see your hand.
I did not get the second question when that where int returns only 2.
Okay, let me go back to that one. So this was the first one. You mean this one?
Yeah.
No, this is the one that returns 1.
Yeah, this one. Sorry.
Okay, so here the way this works, once again, we call the function. The function prints 1, so that's where the 1 comes from. Then the function returns 2. What this means is that the string 2 is actually placed here. So now this line would read result equals 2. So now we have the string 2 stored inside the variable result. But we're not doing anything with that variable. We're not printing it anywhere because we commented this line out. So we have this variable stored in the memory, but we're not using it in any way. So that's why there is no 2, there is only 1. Does that make sense? Do you understand that logic?
No, but we just stored the 1 in result, right? But we are not printing the result. So how does it print 1?
It prints 1 because we have print 1 inside the function. This is where it prints 1. It does not print 2, which is returned.
No.
So this line, the line that says print 1, it works because it is not in any way connected to the result or whatever. If inside the function it says print 1, it just prints 1. The 2 is ignored because it's not printed anywhere. Okay, does that make sense?
Yeah.
Okay, excellent. So I would then propose, let's talk about the Fizzbuzz problem. So what the Fizzbuzz problem does is give you a constant which is max value, and I think in the assignment it's 17, max value equals 17. And so for every number from 1 to 17, you have to print fizz if this number is divisible by 3. Otherwise, you have to print buzz if it's divisible by 5. You actually have to print Fizzbuzz if the number is divisible by both 3 and 5. And otherwise, if it's none of these 3, you just have to print the number itself. So if we look at an example of running the program, it would go 1 to fizz, because 3 is divisible by 3, 4 buzz, because 5 is obviously divisible by 5. Then we have fizz once again because 6 is divisible by 3. 7, 8 are not divisible by, they're not divisible by neither, 3 nor 5. Fizz for 9 because 9 is divisible by 3. Then you have buzz for 10, fizz for 12, and 15 is the first fizz buzz because 15 is the first number which is divisible by both 3 and 5. And then you have 16, 17, etc., etc. So this is the output that your program has to give. And the reason why we talked about functions is that you would actually have to create a function which is called Fizzbuzz. This function will take in a number. It could be any number, 1, 7, 348, 1512. And based on this number as a parameter, you would actually need to return the appropriate result. So result could be fizz, the string fizz, it could be the string buzz, it could be the string fizzbuzz, or it could be the number itself. So you got, for instance, the number 4, you actually return the number 4. But if you get the number 3 as a parameter, you need to return the string fizz, and so on and so forth. And you will call this function multiple times inside the loop. So if we want to check all numbers from 1 to 17, you need to run a loop which would do that. And for each iteration of the loop, you will call the function once and print the return value of that specific function call. So once again, we have Chris saying, let's do this. But the way we're going to do this right now is in breakout rooms. What I'm trying to understand now, we have Vicky.
Okay, so Alex, so we have 1, 2, 3, 4, 5, 6, 6 section leaders.
That's including me and you, correct?
That's including you and me, and so we're gonna divide into 18 breakout rooms.
Okay,
and
3
so that's
per.
gonna be about like 5 people
Okay.
per breakout rooms, and the breakout rooms are going to be random. And then I've posted in the chat to each of the section leaders privately, like what breakout rooms they'll be assigned to. It's basically just alphabetical, and so you'll be like breakout room 1 to 3. Bob would
Okay.
be 4 to 6, etc. Okay.
Okay, excellent. Thank you.
Okay.
So,
And so we're gonna, how long do you want to do this? Because we're already at 8:20. You
I
gotta
know,
time yourself.
but I would still give people time to actually try and work through this. I think we need to do 15 minutes.
Okay. Okay.
Okay,
All right.
so you'll be split into breakout rooms right now, like 5, 6 people to a breakout room. And what you would need to do is actually for one person to share your screen with this assignment.
I think they can figure it out. Okay.
Yeah, of course. But then the people will
because
just
they've-
sit around and do nothing. This is not the first time I'm doing this. So guys, someone would have to step up and say, okay, I am going to be the person sharing the screen. Here is the problem. Let's discuss it together and write the code for this problem together. Shall we? Are we ready to send people to breakout rooms?
Yeah. So
Okay.
I'm gonna create the breakout rooms. Okay.
Okay, cool. Thank you. Okay, I'm then off to room 1. I think we can start just
1, 2, and 3.
1, 2, and 3. Yes. Okay, cool.
Hi, Vicky. Quick question.
Yeah.
They should be coding in the code and place ID.
Yeah.
Okay, got it. Thanks.
Hello.
Hello.
Hello. Hello.
Do you have any questions?
Uh, None as of now. I
Okay.
don't think so. If anybody else has any questions, please.
Okay. Okay. I will circle back. Okay. I'm gonna check on the other two breakout rooms, but I'll circle back.
Yeah, sure.
Yeah.
Okay. So perhaps I can share my screen,
Yeah.
and my code is not working
Yeah,
as
I'll
I
help with
intended.
no problem. I'll help
Okay.
with the code.
All right. I'm assuming that everybody's happy with this. So let's share my screen. So I just created a code specific for life after CIP.
Yeah,
And
but there is already
a number.
Hello.
Hello.
Just
Hello.
checking in to see if you guys have any questions.
We just shared my screen and we're starting to discuss the rule and what's the first step we can
Okay.
take.
Okay. And so I'll be popping in and out. And so if you have any questions, okay, feel free to ask. Okay.
Okay.
Okay, thank you.
Okay.
Yeah.
Hi everyone. Just wanted to see if you have any questions so far.
Hi. Nobody's
breaking through. Needed like 15 seconds more. Bob, what about you? How did your rooms go?
Yeah, my rooms were pretty good. Not everybody could turn on their camera or have audio, but they all contributed, and everybody got a really good solution. I was telling them that, I compared it to my solution from last year when I was a student, and there were some really, really elegant solutions here. Really,
Okay.
really slick, really,
Cool.
really quick.
Cool. That's good to hear. Vicky, what about your rooms?
I think since I was texting you, okay, I probably didn't watch them as carefully, but at least two of the three rooms did solve them.
Okay, super. Leah, what about the rooms you were in?
My rooms did great. Most of them had
Nice.
the exercise solved. One of the rooms unfortunately couldn't share the screen, but they were talking to each other, and I think they did a really good job. So
Good
proud of
stuff. Good
them.
stuff. Emma, what about you?
My rooms did great. Everyone finished up. Yeah. Some finished really, really early. Everyone had time
Super.
to chat at the end. It was great.
Super. And Jake, what about your three rooms?
Jake actually said he couldn't do the breakout room because he's at work, and so
Okay.
he actually
Okay.
didn't
Okay, no problem.
do the breakout.
Still, let's do a quick overview. Let me share my screen now, and I see like people seeing each other, people from last year's, like Leah, Chrissy. Yeah, we have quite a bunch of people from last year here.
Hey,
Loving
Min,
it.
did you do rooms too, Min?
Yeah, sure. My rooms were great. One room didn't have.
Okay, Min, I didn't see you there. Did you join later?
Yeah, I was
Good
here
to
like
see you. Good to see
over
you.
an hour later.
So your rooms did good as well.
Yeah.
Cool, cool. So let's do this quickly. Let me share my screen for the Fizzbuzz, and you'll help me out now, and I'm sure we'll do this very quickly. But just to make sure that everyone's on the same page, and there are a couple of things that I wanted to highlight. Can you see my code right now? Or my lack of code? So let's do this quickly once again. Raised hands, whoever wants to start. My first question would be, how do we modify the main function in order for it to do? Mansi, give me your take on the subject.
Okay, so we want to have a loop in the main function, and
Okay,
we
do you
want
want
to
a for
move
loop or a while loop?
for because I know how many times I want to run it.
Exactly. Yeah, so we know how many times we want to repeat. So what would we write here?
I in range 1,
Yeah.
bracket 1, comma, max value plus 1, because it's an edge case. Yeah.
Okay,
And
so a brief explanation, why did you do 1 comma max value plus 1 and not just max value?
because it doesn't include the last value when we do this. Like if it's range 2 to 8, it will only go to 7, not up to 8. So we have to do plus 1.
Okay, yes. So if we want to have from 1 to max value, we actually have to include 1 or max value plus 1 at the end, because the last value is never included in the range. This could actually work with simply max value. So there are, like always, there are different ways of solving this, but this is one of them. I agree with it. And what do we need to change in lines 7 and 8 for this to work?
Okay, in line 7, we have to replace the integer 1 with I, because we want to change the value. Yeah.
Exactly, because this will be the iteration value which will cycle through all the numbers from 1 to 17, and we want to pass that value as an argument to the Fizzbuzz function, so that it would call. So, Mansi, thank you on that. Can someone else take me through the logic of the Fizzbuzz function itself? So we're passing an argument here into it. It's saved into a parameter called n. So Lyman, tell me, what do we need to do here?
Now we need to write the conditionals inside the loop.
Yes, and this is important, obviously. So let's start. What is the first condition that we want to include here?
The first condition should be the one that combines both divisible by 3 and divisible by 5.
Yes, why is it important for this condition to be the first one?
It's important because otherwise, because Python will read it from the beginning to the end, and if another condition is satisfied first, then some number that should satisfy both will go into that condition. So for example, number 15, which is divisible by 3 and 5, would go to just divisible by 3 or just divisible by 5, because it would be the first one. So we need to include the first one combining both.
Exactly. So yeah, that's good insight, because the order of conditions is important, because the first one to be satisfied is the one that's done. Okay, so let's go with the first one. What would the condition be here?
So if I mod 3 equals 0, and I mod 5 equals 0.
What do we do then?
Then we print Fizzbuzz.
Okay, so this is your proposal. Am I correct?
Yes.
Okay, can anyone shout out once again, show of hands, what would the issue be here? Because there are a couple of issues that we need to fix here. So Mansi, I see your hand, so give me one issue, which is like, take one of the issues we need to fix.
Yeah, so after printing it, it will still be returning n. We don't want that. Like it will print Fizzbuzz and also print the number. We don't want that.
Okay, so how do we fix this?
Use return here instead of print and return a string.
So this is important because we're actually asked for the function to return something, and this return value will be printed here. So instead of printing Fizzbuzz, we need to return the Fizzbuzz string. So Viv, I see your hand as well. Can you help me out with the second thing we need to fix here?
Yeah, I think we need to use and as the parameter when we are defining the function instead of I.
You mean here?
Yes.
Yes, because this is important because the parameter is called I, the argument is called I outside of the function. But when we actually pass the specific value, it's stored in a parameter which is called n. So inside the function, we do not know what I is. The function is not aware of the I variable. It only knows the n parameter. That's why we need to include n here. So thank you for those two corrections. So after this one, what should the next condition be? And how do we write it? Anyone? Or Viv, do you want to take this one up as well?
Yeah, we need to define the other two conditions. One is when it is only divisible by 3
Okay, how do we write that?
condition.
So can you give me the specific code?
If and module 3 equals 0, column, return fizz.
Return fizz. And here's one thing that I wanted to talk about because I heard this discussion in one of the rooms, and I think it's an interesting discussion. The question was, do we use elif here or do we use if here, and is there a difference or not? And the interesting thing is that we can use if here, although if it were if it weren't a function which would return values, we would use elif. And I would say the correct thought process here is to actually use elif. But can someone tell me why we can actually use if here and get away with it? Any ideas? Remco. No, I saw you raise the hand and lower your hand. Did you?
Yeah, well, thank you. Well, if the first if statement is not going to be true, the Python interpreter will continue, so it will just find the next if.
Sure, but what happens if the first statement is true?
Then the return statement will end the function or will terminate the function. Yeah.
Yes. So the reason why we can use if here is because if the first condition is true, we will return from the function. And remember, the function terminates at the first return. So we will not reach this line if the first condition is true. If it's false, then we go to the second one. If that one is false, we go to the third one, and etc., etc. So in this specific case, we do not need to use elif. But if it were a regular conditional expression, we would need to use elif because otherwise those would be two separate conditions and both of them would work and you would get both. For instance, if we use print here, we would get both Fizzbuzz printed and fizz printed.
Yeah, but may I add one more thing? Because my first raised hand was about something else. And in the first if statement, there's a little mistake. Does anybody see it? It's a tiny mistake. But
at the moment, even I don't see it.
Well, the assignment says that it should return something, but it returns something else technically. It's almost the same, but there's
okay, sorry. You mean, for some reason I thought that it should be capitalized. It's not. So yeah, thank you for being attentive. I missed that one. Yeah, you are absolutely correct. Yeah. I misread the assignment itself. Okay, so the third one, obviously, we would have if n is divisible by 5 without a remainder. In this case, we return buzz. And then the final, what do we, is this enough at the end or do we need to add anything? Flora.
We need to add an else.
Okay, so you'd argue that we'd need something like this,
else
and else return n. Okay, so this is correct once again from the perspective of the general conditional logic in which you want only one of these four things to happen. But actually, we do not need the else. If we do this, this would also work. Any idea why?
Because we are not using elif?
Yes, but I mean, why can we get away with this? What would be
after the return, the function is terminated.
Yeah.
Yes, it's the same. For instance, if this is true, the function is terminated. If this is true, then the function is terminated here. If this is true, the function terminates here. And if none of these true, we automatically come to this one. So in this case, there is no need for else because the only way to reach this part, if all 3 of these are false. So this is something you can bear in mind when you're writing, functions which return values as opposed to conditions which actually do something. Because once again, if we were printing this, then we would need to have else, because otherwise this would be printed in any case, which is not what we want. But return sort of says we're done here.
Yeah, but Alexander, if you allow me,
Sure.
I tend to have the opinion that elif would be better in this case. That if you are going to run a script or a function, and you are going to check on different things, that you use a new if statement. But if you're going to check on the same thing, and you want to check it again with an if statement with a Boolean expression, that you would use elif, so that it's clear that as a programmer that you intend to have that together.
I do agree in the sense that from the terms of logic, using elifs makes it clearer what the logic is. So you immediately see it's either this or this or this or this. I agree. I'm just saying that this code would work the way expected, and I wanted to talk through it so that everyone understands why it would work, to sort of underscore the idea that return terminates the function, and you would never reach below this return, for instance, if this condition was true. But otherwise, I agree with you completely. If you want your code to be crystal clear in terms of how you read it, I would obviously use elif and else, and there is nothing wrong with that. So yeah, cool. But let us actually run this code and see whether we get what we want to get. So here it's run. We have 1, 2, fizz, buzz, fizz. At 15 we have fizzbuzz. We have from 1 to 17. So I think we can all congratulate ourselves. We got the result. I don't know why it says to sum here, but it's obviously the correct result for the fizzbuzz. So we're done with this. So congratulations. I think all of you did a very good job solving this. Obviously, we have only 6 minutes left. Our first session did not go as quickly as we initially thought, because that's usually the way it goes. So I would probably, Vicky, this is something I'd discuss with you. I know we have the baby snake problem, and the baby snake problem obviously is a bit more involved. It has like 5 milestones. It's unsolvable in 6 minutes, even if I just do it silently without explaining anything. It needs more time. So yeah, the question is whether we actually want to start right now, or maybe move it to week 3 when we're going to discuss other assignments, and maybe just take questions right now.
So, I mean, maybe you can ask people what they would prefer to do. I could certainly leave the Zoom on. I have to go work.
I see people saying week 3, please.
Near future. Okay, so let's see, week 3. Okay, which means, because week 3 there's another long problem. Okay, and so
we'll discuss this with you. I don't think we need to discuss it right now. We'll come up with how we're gonna handle that. I'm just thinking that people say our brains are already full, so baby snake is not gonna make its way into those brains.
Okay.
Baby snake is yeah, I agree with Flora. It's a fun assignment. We need to do it. Is it possible to solve on an iPad? I have no idea, Don. I have no clue. I don't use an iPad, so I can't answer that. It would probably be difficult because you'd need a keyboard to control the snake, and there is there is technically a keyboard, but it doesn't have the arrows, so yeah.
Okay.
So next time, Vicky's making fun of me saying I talk too much. I do talk too much, but I'll try to be more succinct next time. Saba, I see your raised hand. Do you have a question?
Not really a question, a suggestion, and I saw it in the saw it in the chat. I haven't really had a chance to even look at that probably, and maybe other people have had the same issue. So my suggestion is, and a lot of people have made the same one, is that we try to work through it as much as possible before we discuss it the next time with you, so we don't have to so we only have to concentrate on the problems.
Sure, and that's the thing that we talked about in the beginning. It's very helpful if you actually spend time on the problem yourself, because before coming here, so that the time we have is spent more fruitfully. If you have some issues, we can actually discuss those issues instead of trying to figure out how the problem works. So
I mean, the problem is, with close to 100 people, we can't really expect everyone to have the time every single week to have worked through the problem. I mean, it would be fantastic if that were the case. And so basically, Alex kind of have to cater, not necessarily to the lowest denominator, but he can't teach to the highest denominator. He kind of have to cater it somewhere in between and can't assume that everybody has looked at the problem.
Flora, you have a question or comment?
No, I have a comment actually. Since, as she said, we might not all have the time, but I'm one of those who already solved it. But maybe a good advice is place one person that has solved the issue in every break room, so they can help making things going faster in case we want to solve it in break rooms again. If we
we're
just have at
probably
least
not going to solve the snake in breakout rooms. You'd actually need a lot more time to go through it. It's a more complex assignment. But yeah, I think the idea of actually placing someone who knows the solution, it's a two-edged sword, in the sense that sometimes a person who knows the solution can take too much initiative and just tell people the result and say, like, guys, here's the solution. I figured it out. So no.
Okay.
Okay. Any other thoughts, comments? We have like
Well,
a minute.
the only other comment I would say in response to Flora's question is that was what the SLs was supposed to do. Because we weren't really sure, how many have actually done the problem. And so basically the role of the SL is to try to prevent people from getting actually really, really stuck. But, I do agree, having somebody that kind of knows the problem, having solved the problem in each breakout room would be nice. And then somebody
It would
said,
certainly be helpful. Yes.
right. So someone said should get more SL to participate. Yeah, that would be nice as well. I tried, but because we're all in different time zones, I wasn't actually even sure we would get this many SLs showing up today. And so I'm very grateful for everyone who could make it. And then especially to Emma and Bob, because I had told them they'd be out of here by like 7:45 and it's 9 and they're still here, Belyakov. Okay.
Well, I'm supposed to be here until 9, so yeah, I'm here.
Yeah, but
I can't leave early.
But I told them that they did not have to be here.
But did you ask me? No. All right. Yes, I also wanted to thank all the section leaders who were here. It's much appreciated, your help, because we did not expect so many people to show up. Really, we thought we'd have twice, or half as much people. So it's actually very encouraging to have so many people interested. So yeah. This is it for. Thank you very much for being here for week 1 of Life After Code in Place. I will see you in week 3. So a reminder. So next week will be at a different time, a different actually weekday with Chris. You're going to talk about data analysis and GitHub and Jupyter Notebook. And on week 3, we're going to come back to some interesting assignments. We're not going to miss Baby Snake, so I can promise you that we'll work on it. Yeah, I think we're done for today.
Just one final announcement. I will post a video probably within the next couple of hours. And then I'll have a folder on the Google Drive and then with solution of the code. And then if Alex can make his slides available, I'll also post those as well. And yeah. So if you guys have any comments or feedbacks, just send them to the Gmail. I won't check them every day, but I will take a look. Okay, thanks.
All right, so thank you everyone, and see you next time. Everyone, bye-bye.